Well, thank you everybody for joining another GraphGeeks in discussion. Today we are joined by Max Latey, CEO and founder of Pinboard Consulting. Pinboard Consulting helps people with graph solution, getting graph solutions into production, as well as with graph analytics. We're going to talk about and dive into label property graph schemas, which is a really interesting area. And a funny story about how Max came to my attention is within the GraphGeeks Discord. He was always dropping these really insightful little bits of wisdom about property graphs, and I thought, I have to meet Max. So with that, we started our discussions, and Max agreed to join and share some of his wisdom with us. So Max, can you tell us just a little bit about yourself, and then maybe dive into these property graph schemas?
Yeah, happy to. Look, thanks so much for the intro. I've never heard my words called wisdom before. That was very flattering. Thank you. But yeah, like as you say, Pinboard Consulting, we're a system integration consultancy. We help people put in graph technology, do graph analytics. My own background way back in the day was physics. I was a physicist. And then, a bit later in life, went back to university, did a master's in data analytics, specializing in network science and graph theory, did my master's dissertation in neural social networks and network analysis, looking at power laws, and just love the subject, love the field, love the technology, love helping companies. And I think maybe a little bit like you, I've found that the schema space is underserved. It's underserved. I think too much is taken for granted by people who already kind of know things. And so if you're coming new into the field, it can be, it can take a while to find your feet. And so, thank you so much for inviting me to talk about this. And my hope is that this helps other people, get into the world of LPG schemas. I like to start with a joke. And I hope that it'll become kind of clear what I'm talking about with this. So there are these two young fish swimming along, and they happen to meet an older fish swimming the other way, who nods at them and says, "Morning, boys, how's the water?" And the two fish swim on, and then eventually one of them looks over the other and goes, "What the hell is water?" Right? This is the water. This is the water we all swim in, right? Networks are all around us. If you come from a network science background, we'll get into that in a minute, but nobody ever really explains to you as a fish swimming in the graph world, what's water, right? What is the OG schema? What is the water we swim in? And as far as I'm concerned, thing related to thing with a self edge, this is the schema that nobody ever gives you. And it can be anything. It can be person knows person. I know you. I'm fairly confident you know someone called Matt. I don't know for sure, but I've kind of put down Amy knows Matt. If you want to look at a train station or a network, you might have Kilburn Station, where I live, to West Hampstead, the posh area next door, Finchley Road, just a bit further from West Hampstead. They're connected together. But this whole concept of a thing related to a thing, everybody talks about the graph. Everybody starts with a graph. Everybody looks at a network, a graph representation of a network, and nobody ever kind of really starts with the OG schema, the original gangster, right? Thing connected to thing, thing related to thing. And it genuinely can be anything, right? We've got train stations, airports, internets, website, social networks, person knows person, person hates person, person follows person. They're all this schema motif of a node type with a self-edge type. If, like me, you come from kind of a network science and graph theory background, then Networks by Newman will be one of your touchstones. I've got a copy sitting on my shelf, literally, 8 feet to my right. Never shows the schema. You can go through and look at bipartite graphs, entire chapters on bipartite graphs, never shows you the schema. Person gives rating for film. Person has predicted rating for film. If you're trying to do link prediction, for instance, the graph is given, but as the reader, as the person moving into this journey of graphs, no one ever really gives you the schema on the right. Another book, if you're looking at multi-layer networks, by Ginevra Bianconi. Big shout out to Professor Bianconi. She was my dissertation supervisor. Best dissertation supervisor you could ever hope for. Wrote the book on multi-layer networks. And again, huge numbers of diagrams, fantastic visualizations about these multi-layer networks. Never takes it to a schema. So at the fundamental level of the grounding in this science and the grounding in this maths, schemas are never really discussed. because maybe they're seen as something to do with the technology rather than the mathematics. But to my view, this is maybe a bit of a gap, a bit of a hole. I don't know, is this something you've kind of seen in your journeys through the literature, that networks are well described and schemas kind of aren't?
I would agree. I was just going to ask why you think that, what's the root of that, because that is a fascinating observation, and maybe it's just it is seen as something that is a computer science implementation detail that doesn't need to be worried about. But if you think about, making progress and running experiments, how do you do that without some kind of structure for your data? Actually, have you asked any of your former professors or people in the network science space about that?
That's a great idea. I should actually just call up Ginestra and say, oh, by the way, but she's busy solving quantum gravity, so I don't know if she'd have time to answer that one, but maybe.
Yeah.
But yeah, look, I think perhaps it's just seen as too obvious. Why would you even bother with the right-hand side of this diagram that I've got up on screen when you've got the left-hand side? And actually, this is something I'm going to kind of get to later on in the slides. But yeah, potentially it would never occur to them to write it down because they've already built that model in their heads. And I guess maybe they just assume that other people will also build those models in their heads. But yeah, I mean, for those of you who are watching this completely fresh and who potentially don't even know what a label or a property is in relation to an LPG, I thought I'd just kind of quickly put up this slide. The labels, what you might think of as the types or the classes, maybe if you come from a programming background. So a person would be a node type. Beatrice would be a node. Andy would be a node. So the labels are the types of objects. So managers is a labeled edge type. It's a relationship type. So in this particular instance, you have an instance of this label, which is that Beatrice manages Andy. And there's a property on that particular edge of when did she start managing Andy? Well, she started 1st of January 2024. You can have other properties, unlimited numbers. Name, in this case, I just put simple name, but it could be first name, second name, middle initial, title, etc. And those are the properties, sometimes called attributes. Apologies if I dip into calling them attributes. I use those two terms interchangeably, but of course, as we're LPG, I should, of course, be calling them properties. And then what's a schema? Again, not trying to get into semantics or ontology, but to my mind, a schema is a definition of the elements which can be present in a graph. So what you're looking at now is not a schema. What you're looking at now is an example of a graph. What we were looking at before on the right-hand side would be just a visual schema. And what we're looking at here, way back in the OG, on the left-hand side and at the top, those are schema. So schema on the left and the top, graph on the right. I guess I'm hoping that's sufficiently clear and trivial. But yeah, where did it all come from? As a concept, it kind of did exist before 1976 when Peter Chen published his amazing paper on the entity relationship model. So the Chen entity relationship model, which is a very strong precursor to the LPG model. So label property graphs have come a long way. You can see that there are some differences, but fundamentally the structure is the Chen entity relationship model. And that still exists. There are people who still use the Chen entity relationship model to model all kinds of things, not just graphs, relational databases, Postgres, NoSQL, etc. It's a logical modeling methodology, but it's very much the driver and still a touchstone. So I'm part of the LEX working group on the LDBC GQL schema design. We'll kind of come on to that in a minute. And we still refer back to this. We use it as a touchstone for various different parts of our discussions, as well as, other parts of ontology. Is this something which was already kind of, known to you? Is this a familiar model, Amy?
Yeah, actually, this is kind of an interesting area, and I'm glad you're going back to the traditional, entity relationship model. So and I do have some questions about this, but yeah, this is something I've been familiar with for a while, but the crossover to graphs is not always smooth, I guess. I don't know if that's how you've seen that as well.
Yeah, no, absolutely. And yeah, I'm not going to stray into the RDF world. That would be like somebody who rides a bike talking about riding a horse. I'm not trying to say that one's a bike and one's a horse, but yes, technically we both ride things over solid ground to get from point A to point B, but our experiences are normally quite different. So this is a good kind of way to help the two sides meet and discuss, amongst other things. But yeah, it's a great model, and it's still used today for that exact reason. And yeah, as I've mentioned here in the great papers in computer science, which was published sort of late 90s, this was one of the ones mentioned. Chen is mentioned in the same paper as von Neumann, Claude Shannon, these great scientists, and the Chen entity relationship model is there.
So one of the things, so I'll go ahead and ask the question that I've been thinking about since you were sharing the multi-layers, and maybe this is a little bit in the ER model as well, is I've often felt that we as property graph practitioners don't have a really good way to show whether a node or a cluster of nodes is actually at a different layer. And so our schemas often flatten things in a way to as if it's all one graph, but it's at times you're really looking at a graph with different dimensions, and I've never felt like we represented the multidimensional aspect very well. And so maybe I'm wrong, but yeah, if you go from the left to the right here, you can see on the far right where things feel like we flattened them down, and I feel like you lose a little something when they're super flat. I don't know, Max, what do you think?
Yeah, look, it's a fascinating part of the discovery side of what we do. When you're given data representing some kind of network, depending on where that data's come from, the schema will be direct. Like, let's say you've been given some SAP data, and I'll use that as an example later in the talk. You know what the dimensions are. You know what's a customer, what's a client, what's a factory. If you're just given data and said, is this one network? Is this multiple networks? Being able to go from something which is effectively, to your point, flat, and going, actually, maybe there are higher dimensions in here.
Yeah.
Well, community detection is a great way of doing that. Run a walk trap over it, and suddenly you start seeing things, and you go, actually, these are not just communities; these are layers. These are separate networks which interact with each other. It's a fascinating part of what we do, and something that's, I think, an active part of study and an active part of practice. I don't think there's a defined, agreed way to go from flat to a schema, but I think there are paths, and it's something which, as a practitioner, I really enjoy. So being able to look at something which might look like a homogeneous network, and actually you've got features in there which indicate that you might actually have multiple layers that shouldn't be represented by a single node type and a single edge type, but actually you've got two node types with edge types between them and self edges, and actually you have 2 layers in this network, or 3 layers, or 4 layers, or 5 layers. It's a joy. It's a joy when you kind of realize something like that and are able to then try and represent it with a more complex schema, higher dimensional schema, and then play it back and try and go, oh, yep, wow, do this, and suddenly it all makes so much more sense.
Absolutely.
But yeah, I think that kind of actually brings me on quite nicely. Thank you for the question to my next slide, which is really, what is the power of a graph schema? Why do the textbooks kind of overlook it, but why do data and technology practitioners get so much out of it? What is this power which we've found in schemas? And to me, absolutely, far and away, the number one is when you put a graph schema in front of anyone in an enterprise, anyone in a company, whether they're technology or business, they see something that looks like what they do. And if that sounds a little bit fluffy, let me kind of do it by contrast with potentially second normal form. And, apologies to SAP for picking SAP as my example of difficult to grapple second normal form, but this is one small part of the SAP schema. This is a relational database with, join tables, keys. You can see crow's foot notation in there. This is not something which a layperson or a business user would look at and immediately understand. They could get to understanding, spend some time, work out what things are. You kind of build your own mental model, but represented in a graph. And suddenly their eyes light up, they lean in, and they go, that's where my production order is. What do I have? Oh, that's a production order for that reservation. Well, that reservation is for that production order. What's that production order for? Oh, it's to produce that material. And suddenly the conversation warms up. You're not just talking about data and tables. You're talking about their business. You're talking about their lives, their use case, what they do. This, to me, this logical modeling power that LPG schemas have is where so much of the benefit comes from. Of course, we're talking about graph tools, and graph tools have their own benefits, but even in abstraction, just the ability to logically model something in a technological modality that just is so much more natural. Yeah, so powerful.
It's funny, Max, that you say that, because I've had this conversation with other graph practitioners, usually ones that have been in this space for a long time, where it's hard to explain to somebody who is just thinking from a computer science standpoint of, well, I just need to process my data. That's all I care about. Data engineer, I'm just processing, or whatever the position might be, when you forget the importance of domain expertise to be able to interact and work with the data itself. It's not just about processing data in a business. Something has to be done with that. You have a domain expert that is either going to make it some kind of analysis, or you have a business person who's going to make a decision. And if they can't wrap their heads around the data they're looking at or how it interrelates, the decisions are poor, the analysis are poor. And I think not taking that into primary consideration is such a mistake, because what are we doing with all this data if it's not serving a purpose? And I think the graph schema, as you're saying, the power for me, it's like it links the purpose of the data in the first place into the data. So I love this slide. Yeah.
Thank you. And funnily enough, very, very, very recently, I think literally within days, depending on when this goes out, SAP have just announced that they now have a native knowledge graph on top of their relational schema. As it happens, they've gone RDF rather than LPG, but the benefits are still there. I'd let an RDF person talk about the details, but initially they've done it for AI, right? That's the why. They've done it AI. Enrich their AI, enrich their agentic landscape, have something that's already there so that people don't have to do it themselves. They don't have to make their own LPG schema or RDF schema on top of SAP. There's an SAP native one. What I think they will find is secondary benefits will multiply, because people will, instead of having to look at the tables on the left, they'll be able to look at the RDF equivalent of what's on the right, and they'll start to understand things better. To your point, they'll make better decisions. They'll have better comprehension. They'll start to get that richness of a good logical model on top of, in their case, a relational store, but something that is far more comprehensible, not just for LLMs, but for human beings. So yeah, very contemporaneous. The side-by-side method. This is something which I use all the time. I've not seen it widely used much, but I'm a huge proponent, and I'm going to use this to evangelize. Some people can think in schemas and imagine a graph. Some people can think in graphs and imagine a schema. Some people find both things a bit tricky. Since almost within the first month or two of launching Pinboard and working with graphs and graph schemas, I just started doing this. And the engagement and the understanding and the comprehension with clients, it's a huge accelerant. I'm a huge proponent. I recommend it to everybody. It does potentially slow you down in the moment. If you're trying to talk about a graph, doing a graph without showing the schema is a little bit quicker because you don't have to draw the schema. Or if you just want to talk about a schema, drawing a schema without doing a worked example, yeah, it kind of works. But I think doing the two together just multiplies the power of each. So anytime I want to have any discussion with a client about a schema, I will always draw an example of the graph on the right, even if it's just a piece of the schema. Like if you've got a schema which is 5 node types, 10 node types, 15 edge types, if we're just talking about, for instance, person to location, I'll just draw out person to location with the edge types and do an example so that they don't get confused about, oh, can you only have one work set? Because people will often see a schema and imagine the wrong graph. Or they'll look at a graph and they won't quite understand that doing them side by side, schema on the left, dotted line, graph on the right, people will get it and they'll reinforce each other. And then when you start writing in attributes or properties, there we go, caught myself, properties like ID, first name, etc., then they can start to understand. Yeah, this side-by-side method, I don't know, is this something, I know you used to work at Neo4j, obviously you've been in the LPG space, is this something which I've just independently rediscovered that's actually common practice? Or
This is brilliant. We should all be doing this. And I've seen both done. Usually the schema is what you're showing because that's the literal detail that you're going to implement. And then I think that you get all these questions usually. Oh, does that mean if this scenario and it would look like this, and someone might actually draw it? And I just realized that you have these conversations over and over again, and you're just being explicit so that we're helping people not have to wonder and assume. And that's like the worst thing if you're working with a client is you make an assumption, they make an assumption that you're both on the same page, you go to implement and it's not, the assumptions are aligned, and then there's a problem. So I'm sure this is developed over many years of working with clients and having those misunderstandings. I love this, and I would absolutely love to see more people doing it. So the side-by-side method,
yeah,
I guess remember that.
I love simplicity, and what I like about this, I take no credit. This, as far as I'm concerned, this concept was in the ether, and all I've done is just materialize it. I take no credit. Good, but yeah, I'm glad you see some value in this. Which brings me on to the good, the bad, and of course the ugly. Schema design. So from the side-by-side method to schema design itself. This is a tricky one to talk to without images, so I'm just going to go ahead and bring up a bad schema. This is a bad schema. It may work. So I'm not going to say whether it does work or doesn't work, but it's a bad schema. And when you've worked in labeled property graphs and labeled property graph technology, as a practitioner, my belief is almost anyone who's worked in this industry for a reasonable amount of time could just look at this and even without reading one single word go, this is a bad schema. There are too many node types. There are no self-edges. If you're in graph technology, the OG schema must appear somewhere. Where is it? Where's the OG? Where's the self-edge? Where's the network? The original schema of thing connected to thing, that represents a network. If you don't have networky data, why are you even in a graph database? On the left-hand side, a string of node type, edge type, node type, edge type, node type, edge type. I call that something very rude. I'm not going to say it on this webinar, but if you look at those, you go, that can't be right. Really? Is that really what your schema looks like? And yeah, it's my belief that as a good practitioner, you can squint your eyes, look at a schema and go, that's just intrinsically bad. There is no way that cannot be improved. And in the end, this was something where, so here's just a little bit of, I guess, information about Pinboard. We are often the second phone call. This tends to be our destiny. We are the second people call. They start with somebody else, maybe just the vendor. Maybe they use, I'm not going to name one, but one of the large SIs. Maybe they use, they've got a graph practice. They have some graph practitioners. They come in and they make a schema like this. It works. People go, oh, okay, that's good. And then maybe it's not fulfilling the promise. It doesn't run too fast. Their queries aren't performant. Then they call me. And we come in and go, you know what, can we rebuild your schema? I know it's a lot of work, but I don't think we can make your queries faster when this is your schema. And we help them make something like this. And my hope is that a graph practitioner would look at the one on the right and go, that doesn't look too bad. You've got some self edges. You've got, some edge types across multiple node types. Maybe some of those could be consolidated. Maybe that's a little bit suboptimal, but, superficially, prima facie, nothing intrinsically, immediately, massively wrong. Maybe some edge types could be consolidated. Maybe some of them could be turned into nodes instead for, reification or, slightly different functionality. But just, again, squint your eyes. A practitioner, in my view, in LPG space should be able to squint and look at the one on the left, squint and look at the one on the right and go, yeah, no, good, bad. I don't know what's kind of been your experience with schema design and maybe coming in second.
Yeah, I was actually going to ask you if you often work with companies that change their schemas over time as well. So that I think what I find interesting is there are certain things that you see happen is people who want to have a different node type or relationship type for everything at first, or they want to possibly for every instance of something, I want a different timestamp, and I'm going to do something by the timestamp. Every day has their own relationship or something of that nature. So there's these interesting creative things that happen. And I think part of it is, and I was going to ask you on tips and how to think about it, is that I think when people get started, there is so much flexibility on how you could model things that most people just feel their way through it. And so you end up with something that's on the left, and things kind of evolve over time. And so I'm curious, one, if you have some tips on like how to think about it, but also if you see this evolution over time of schemas where, maybe the use cases changed, or you acquire another company and you've got different types of data you now, need to bring in, if that's something that you're also seeing. So I guess top tips and then evolution over time. I'm always curious about that.
Yeah, absolutely. I'll address the top tips first. So what you've experienced, absolutely, we've experienced too. My tip with what I call the expansion contraction cycle, where if you're in a workshop, and this is top tip number one, do it in half a day. Don't let this take 3 to 6 months of explosion and contraction. I think you can do this in the logical modeling stage and get almost there in half a day. You start with a gigantic whiteboard. You get people to say words that relate to their space. You've got business people in the room, technologists in the room, data people in the room. You've got them all there. And you just say some words. And you start writing those. Data, you write up data. Plant, you write up plant. We've got spending and finance information. Finance. Time might be there. Time, days, months, years, quarters, brand, whatever it might be. You just start with kind of the word splat. Then as the expert practitioner, the person that's guiding the workshop, you start joining them together. How are these things related? How do they relate to each other? And again, you just start writing words. A supplier invoices a plant. They supply a material, and you start using, subject, verb, object. Again, borrowing some stuff from RDF. I love the RDF world. This is not an antagonistic relationship in any way, but you write words and you come up with a schema. Often, the very first schema you come up with is probably going to be the one you end up with, or very close. But then people start going attributes. Well, maybe that should be a node type. Add as a node type. Oh, maybe there should be 2 edges. 2 different edge types. Oh, maybe actually that needs some sort of like hyper edge. Okay, well, let's do a little hyper edge motif where we change that edge into a node so that we can breify that node type. And you go through this explosion phase where suddenly you end up with a gigantic schema and all kinds of interesting schema structures and schema motifs and cool, funky stuff. And then you can look at it and go, oh, and then you start to collapse again. And often after you've done the expand and collapse, 9 times out of 10, you'll come back to something that's actually fairly similar to semantically what you drew the first time. That's my top tip. Top tip, everyone, one room, just do it. Logical modeling. The more time, effort, investment spent on the logical modeling stage with a good coach and a good practitioner, trying to maybe sell my services a little bit there, but it doesn't have to be me doing this workshopping. It just makes your chance of landing successfully so much higher. But you will, to your point, absolutely go through an expansion and contraction. It always happens. That's just a universal. Expand, contract, and once you contract, you'll end up with something which is very solid, which then brings us on to change over time. Change over time, if you've done the first bit correctly, often they're fairly immutable. Unless you genuinely shift what a customer is, a customer is going to be a customer. Unless you shift what a plant can do in terms of it manufactures things, lots of the fundamentals tend to be fairly immutable. The use cases, they're the ones where they can change, right? If you want to start doing more temporal analytics, you need to look at how you're handling time. Time goes from being a date stamp as an attribute to being potentially a node. Potentially you even shift technology. You go from a pure, graph database to something temporal like Raftery or DynadeX or something, right? Like there can be big shifts. But in terms of evolution over time, simplicity, trend towards immutable data objects tends to be the way. But again, graph technology is really good at handling change, right? It's much easier to change a graph database when you change a relationship than it is to change a second normal form, relational, etc.
I like the message of start simple, let yourself get messy, and then come back to simplicity. I do feel like I see that a lot in just different types of work, whether we're talking about something that might be a little more creative or planning or business strategy. And this is, in a way aligned to, strategy and understanding your data, but just allowing the teams to get messy, but then not being too perfectionistic so that they can so they can come back to simplicity. But just knowing that that's part of the process, I think will potentially give people a sense of allowing the team to go there so they can get all the ideas out.
Yeah, absolutely. And then finally, of course, you can't have the good and the bad without the ugly. There's an ugly schema, but actually not a bad one. So this is visually a representation of the sticks schema. So this is specific to cybersecurity. Cybersecurity, obviously a huge use case for graph. Lots of people doing fantastic things. Wiz just sold for X billion to Google, runs on Neptune, and, phenomenal use case for graph. This is visually the sticks schema. So if you go to the sticks website, you'll get all of the information and you can turn it into a genuine graph schema, which is basically, as an intellectual exercise, I kind of did it with my team. I'm like, let's do this. Let's actually do this. And we did it in Tiger Graph. So in terms of visualization, this is a Tiger Graph Studio visualization. And we've zoomed in on just one small section to kind of show you what some of the elements are. Again, as a graph practitioner, you'd look at this and go, oh, you can collapse those, right? Uses, downloads, variant of, drops, controls. You could probably turn that into one edge type and then just have typing on the edge type, maybe. Again, the same with some of the other edge types. The node types look pretty good. If you actually go into the detail, the node types look pretty good. But the edge type definition and the edge type structure, messy as all hell. But they do exist. And this is what happens if you try and, visualize something which is basically just written in text.
So Max, if you were working with a client that was using the stick schema, would you say, hey, this works, it's aligned to known standards, let's just run with it? Or would you look at this and say, let's simplify so your queries will run faster. Let's simplify so managing it's easier. What would your recommendation be with something like this?
I think it would depend on the strictness. If it was all about absolute strict implementation of sticks, use it as is. If it was about wanting to get the benefit of sticks enrichment for a cybersecurity use case, then I would say, let's make a completely compliant, consistent schema with all this in it that's simpler. Let's collapse some of these edge types and have uses and downloads as a string variable. Let's make it a string variable on a single edge type, right? Variant of Should that be the same thing? Maybe not. Is it a variant of the malware? Let's keep that separate, because malware variants are different to uses and downloads. Drops, controls, could they be separate? Could they be the same? Maybe, maybe not. Delivers users in one direction and users in the other direction. Well, maybe let's make that undirected, right? So yeah, absolutely. It would depend on the use case, but yeah, simplification purposes, absolutely valid.
Okay, that makes sense.
Yeah, really, this was just an excuse to show, an amazingly detailed schema in a schema visualizer.
Yeah. And I love it. And of course, right now, cybersecurity in graphs is, I don't want to say all the rage, but it is definitely getting a lot of attention right now.
Yeah, I mean, Pinboard has literally built a cybersecurity graph product. Yeah, we do occasionally do, product build as well as SI work. And yeah, it's no surprises, cybersecurity. Yeah.
Yeah.
Okay, it does slightly beg the question. So what are some open questions? So we have LPG schemas. We know what labels are. We know what properties are. We know what a graph is. We have technology. Is this a solved space? No. This is very much not a solved space. And we'll come on to some examples shortly. The LDBC, the Linked Data Benchmark Council, is one of the sort of more active participant groups in the graph space. There's the LEX working group, which is the LDBC extended X GQL schema working group, which I'm a member of, kind of participating member. It exists to improve and enhance the schema definition landscape. Look at existing industrial practice. I think that's probably where I add, my little bit of value. I'm not an academic. There's some amazing academics on the committee. I hope I kind of enrich their view with a bit of industrial practice view. They do use ERM, they use EML, they look at, Shackle, they look at RDF, they look at RDF star, they look at JSON schema. They want the GQL schema definition language to be as rich and as useful as possible. But some of the open schema questions, how should schemas be defined? Should we use JSON schema to define graph schemas? How should constraints be applied? And we'll come on to some of the constraint stuff shortly. But yeah, there are still absolutely open questions in the LPG schema space. And the LEX working group, the W3 committee are working actively currently towards these goals to try and help graph technology work as best it can, be the best version of itself. In a lot of cases, the graph vendors do their own versions of these things. Sometimes they do them well, sometimes potentially suboptimally. I won't name names or call anyone out. I don't want to do that. But yeah, this is why, the LEX working group exists. This is why we have the GQL standard. And yeah, we are starting to see in the technology space GQL be more adopted, spanograph. And we have Pinboard has a spanograph client right now, which I can't name, but they're using it. BigQuery Graph is extremely exciting. Altipa is a graph vendor out there with a superb graph product. Tiger Graph is moving towards GQL support. It's growing. Cypher is still kind of number one in terms of languages. Gremlin, great language. People use it. Still has some active and very, passionate Gremlin users out there too. But I think GQL is where a lot of the big guys are moving, right? The big boys. Google, Microsoft Fabric. I don't think they've officially announced whether they're going to be, fully GQL compliant, but I'm sure they'll support GQL. Neptune, I think, is working in that direction. They already support Sparkle when they're treating things as RDF. They support Cypher or OpenCypher when they're treating things as LPG. It's great. It's great to see the vendors coming on board.
Since we're talking about standards, a little, I guess, an adjacent topic is also governance and management. And that's one thing that I don't think we've talked about so far is what are your thoughts on schema management? And, we talked about change over time, but, how do you enforce things? You can come up with a great standard, but yeah.
We will absolutely touch that. You've anticipated one of the future slides. We will get there, and hopefully I'll have a good answer for you. Just immediately before then, one of the particularly interesting constraints for LPGs and graphs in general is cardinality, something which is not hugely talked about or, widely interesting within the SQL, the relational space, or even the NoSQL space, but very interesting in the graph space for the reason I'm about to show you. So graph cardinality. How many edges per edge type are allowed? So the schema on the left supports graph 1 and graph 2. Graph 1, if you implemented it, would be horrific and would violate an enormous number of security protocols. The graph on the right would enforce those security protocols. They're both valid per that schema. So Charlie can have update permission for blue team, update permission for orange team, and update permission for teal team. So the left is okay. Does Max have update permission to all three? No. Max should only have update permission to blue team and should have view permission to orange, and view permission to teal. Both allowed. If you do not enforce cardinality, you can accidentally on ETL or an ingestion or just, potentially poor management, get what looks like a perfectly valid graph, which is absolutely wrong. In terms of schema design, should permission be an edge as a result? Well, in this case, fine. If it was just an edge, it'd be an edge and you'd get rid of this problem. But let's say you want permission to be a node type. So you can, for instance, connect it to something else, granted by, for system, etc. So you want permission to be a node, you want to do it. And how would you do it? You'd add cardinality constraints. You'd stick on, and again, if you go back to the chain entity relationship model, this is there. It goes back to 1 and n, and let's go all the way back, show you in that little diagram. There you go. If you look on the edge types, you can see 1n cardinality, right? Chen was way ahead of all of us. This is just a kind of a concrete example using, I might add, the side-by-side method to show, cardinality and cardinality importance and cardinality impact. Schema management. There you go. We're only one slide away. It is a huge hole in the graph technology landscape. A huge hole.
Yeah.
Some of these schema first graph databases like tygraph, for instance, is schema first, but also the flexible schema databases, Neo4j, Neptune, do have schema management tools. They don't really let you manage your schemas. No version control, no collaboration, no integration with Git or Jenkins. By any use of the word management, they barely qualify as management. Apologies to Tiger, apologies to Neo, apologies to Neptune. Your tools aren't great for schema management. The graph processing engines, so PuppyGraph, Raftery, Spanograph, generally worse. They will have nothing visual at all. So you'll notice in the title, I did say visual schema management. You can, of course, manage your schemas. They're text files. You can manage text files via repositories, have version control and collaboration, branching, etc. But it's not native. It's not visual. You don't see really what's going on. Graph on relational, things like, say, Oracle PGQ, Duck PGQ, you can have visual management and you can have code management, Git integration, but you're seeing tables, right? You are defining your graph using tables, join tables, edge tables, node tables, etc. So you do get access to the relational tools schema management. So Oracle's schema management, DuckDB's schema management, etc. So from that point of view, some of their schema management is more mature, but it's not graphy. It doesn't look like edges and edge types and nodes and node types. Yeah, there are tools. The tooling landscape is improving. 3 which immediately kind of jumped into my mind. We have Charlie's phenomenal tool, GraphBuild, fantastic tool. I recommend to everybody to go and take a look at that one. Schema visualization, editing, collaboration, sub-schemas, full schemas. It does other things too. It also has, a fantastic ETL tool. You can, as the name implies, build your graph. But for me, for this particular, webinar, we're talking about the schema management. It's schema management tools, best in class. GraphBuild and Hackalade, in terms of schema management, they are the 2 best in class. And Hackalade's fantastic. The support is growing within Hackalade. At the moment, I think it only covers about 3 or 4 of the LPGs. It does cover some of the Gremlin graphs. So it does cover Gremlin as well as Cypher and Cypher-like languages. G.V is there, but really that's not schema management. That's kind of just schema visualization because it depends on the tool that G.V is on top of. So, MemGraph has its own schema management tool, again, similar to some of the other tools. But yeah, really, this is it's a space where, Accolade, GraphBuild are really stepping up, helping. But yeah, it's still, from a vendor point of view, something that the vendors themselves have not put a lot of time, thought, effort, investment into really building up and maturing.
So question for you: do you see vendors or certain vendors adding more of this capability in, or do you feel like it depends on the type of tool? Like if you're a database tool, your mind is all about ACID and how do you effectively store things in a very compressed manner. If you're a compute engine, you're all thinking about like, how do I process this as possible? And schema management so closely tied to understanding data and data management itself. Should that be done somewhere else? Should that be done outside with experts in not just that, but experts that focus on schema building and schema management as its own discipline? Like which way do you see that going?
I think from my discussions, and I won't name names, most of the vendors would probably love other people to do this. I think they would love Accolade, GraphBuild, G.V to become the tools for schema management. I think they'd love that. And they would work with them, and that's absolutely you. Is that the right and wrong? I'm not gonna say. I certainly see that as their view. Somebody else's problem, somebody else's joy, somebody else's benefit. Somebody else's license, somebody else's use case. I think they would much prefer it to be the Accolades, GraphBuilds, and G.Vs of this world than the, I won't say names, but yeah.
Yeah. No, I can see both sides of that. One is if I'm a user and it's integrated into the tool that I'm using, that's awesome. I don't have extra licenses. I don't have other people to have to work through support. But I also think it's so tied to the domain that it may, it's something that, people who are experts in that probably aren't also experts in everything else to do with graphs. So I could see either sides of that story. So I guess we'll wait and see. Yeah.
Yeah, absolutely. There are also just pure visualization. So all of the diagrams in this presentation have been done in Lucidchart. They could equally have been done in Draw.io, Visio. There's ArrowZap, which is sort of Neo4j powered. Good tool for doing, this kind of schema visualization. But yeah, if we look at this was Lucidchart, right? It's my go-to because at the moment, I can't do the side-by-side method in any of these tools. Accolade is a fantastic tool just for doing the schema. But what if I want to show a graph? Right. Same with ArrowZap. ArrowZap, you can kind of do it a little bit, but not hugely well. So even though, Lucid is not, you have to do this manually. You have to put a circle, you have to put a text box, you have to type text. It's not ideal. It's still my favorite tool for logical modeling because of basically the side-by-side method. If I was just doing schemas, GraphBuild, Accolade, fantastic. If I was just doing graph visualization, some other tool maybe. But yeah, to do the side-by-side method, to properly bring things to life for people, I can now do things very, very quickly in Lucidchart /Draw.io/Visio. So yeah, awesome. To me, that's the landscape. And that is also the end of everything I had prepared. So yeah, I guess anything we want to talk about before we wrap up?
Well, I guess I always am. Well, first off, Max, just thank you for the overview and the tips and caveats around working with property graph schemas. I think, it's one of those topics that is just foundational. I hope obviously foundational to having a good, successful graph solution, but that is often left to your own devices to figure out. So just very appreciative of you doing this for the GraphGeeks audience. And you can always find Max on GraphGeeks Discord and ask him extra in-depth questions. But I always am curious. So this is something I like to understand from everybody who I'm talking to. Like, what are you most excited about in the landscape right now, either from a technology standpoint or maybe some business shifts or some standard shifts? Like what excites you for 2025 in this property graph and I would say property graph and schemas. So I'm going to make you tie it back to schemas.
Awareness and adoption. Like, our world, I think, is quite small still and needs to be bigger, but it's growing. This is what excites me. I think SQL 2023, GQL, the adoption of GQL, the fact that the tools are getting easier, the fact that you can have a graph database, but you don't need a graph database to do graph. These are the things which excite me, because what's happening is people who've spent their entire lives and careers in tables and data frames, tabular, columnar, matrices, the growth of simpler tools is really helping that awareness and adoption. So, of course, everybody knows about GraphRag for LLMs. That caused a huge wave of interest in graph space. But really, to me, that's a spike, right? That's a one-off. The general foundational graph awareness and the growth of awareness, thanks to things like SQL 2023, GQL, the wider adoption, more of the large vendors starting to make products that allow people to do graph with a really thin stack. That's what's exciting me. So BigQuery Graph, call out to Google. I'm excited about BigQuery Graph. It comes out. Microsoft getting in with their, secrets graph project. That's going to be not so secret, hopefully very soon. The push that Amazon and Neptune Analytics have done for graph, Oracle Graph, PGQ, all these things which are starting to expand. SQL 2023 on top of MS SQL Server. This is what really excites me. I want more people to be able to think in tables and be able to think in terms of thing related to thing. I want people to start seeing this and understanding it and recognizing it and going, we have network data. We have thing related to thing. We need to link these tables in a different way.
I love that. And I do think that expresses what is going on right now is the diversity of approaches, the hyperscalers getting in as well, which just adds credibility, but also resources and thought leadership as well. Like, it's just, kind of pushing things forward, is really excited. And as you were talking, I was imagining, is it a new company that's going to be called Things and Things or something like that? But I could definitely see, that mentality of, as opposed to talking about, here you have a complex graph problems, everybody has things related to things. And the more we can make it easy, regardless of where your data sits or what format it is in, to do some graph, I think we're just going to see this like acceleration of graph. And at some point, when people stop calling it a graph, maybe we've been successful. It'll just be somewhere hidden in the implementation details.
Absolutely.
Awesome. Well, I think we'll have to leave it just for time. Leave it there for now. But it's been so wonderful to have you on, Max. Really appreciate. As I said, people can find you on Discord, but how else might they get a hold of you?
LinkedIn's good. I'm pretty sure I'm the only Max Latey on LinkedIn. I haven't checked recently, and also just on the website, Discord on the GraphGeeks. I'm fairly active. I monitor that one. You can DM me. Yeah, I try to be easy to contact. I don't hide myself away.
Awesome. Good. Well, and we appreciate that. All right. So we'd love to talk to you again someday in the future, and I'm sure we will. But thank you again, and thank you everybody for listening.